Hello everyone, this is Prem Kumar and I am here to speak about my laboratory 2 of EE542 Internet and Cloud Computing. This laboratory is about Linux socket programming using TCP. Here the client server model is explained. So most of the inter-process communication uses client server model, and client always needs to know the address of server, but the server doesn't need to know the address of the client prior to the connection. And when both are connected, client and server can both send and receive data, and they can participate in the communication using sockets. Here the steps involved on the client side and on the server side is explained. So on the client side, the first step is using the socket system call to create a socket, then connect to the address of server using connect system call. Then when the connection is built, sending and receiving data takes place through read and write system calls. On the server side, it is the same thing. The socket is created using socket system call, then bind the socket to an address using bind system call, listen for connections using listen system call, accept a connection with accept system call, accept call blocks until a client connects with server. When the server and the clients are connected, send and receive data as and when it is required. Transmission control protocol is one of the main protocols of Internet Protocol suite. Then it provides host-to-host connectivity at the transport layer. TCP is widely used in World Wide Web, email, file transport protocol, secure cell, peer-to-peer file sharing. And TCP provides reliable, ordered congestion control and error detection and correction. Then TCP uses three-way handshake, that is sync, ACK, and ACK. And modern implementations have slow start, congestion avoidance, fast retransmit, and fast recovery. Alternate protocols are Vegas, Westwood, Vino, and Santa Cruz. Procedure is again repeated as in the first experiment or the first laboratory. Here what I do is I'm gonna log in into my MyReader lab. Then as you can see, there are two experiments that are active. So this is the experiment that I'm gonna use. Then I would it is already swapped in, so I don't have to swap out now. It has to be active. It is active, the status is active, and this is the details of the experiment. Then this is the visualization. So these are the nodes that are implemented, and this is the LAN connection that has been implemented. Now the experiment is active, so I'm using two terminals, one for client and one for server. So I SSH into my DITR lab. So I'm into it. Now I'm gonna SSH into node B. Here I'm gonna SSH into node D. Now I'm going to Prem. Here when I do ls, you can see I have server.cpp, and the same thing here, client1.cpp. So I'm going to execute that. Then this is the port number. This is the node D. Then the port number. So please enter a message. You can see I typed hi, how are you from the client side. That was received in the server. Hi, how are you? And server sends I got your message. This is the acknowledgement that was received. The server code that was implemented um, uh, has problems in it because it cannot handle multiple simultaneous connections. So we need to make few changes, and that is done in a function called do stuff. The changes that are made are put the accept statement and the following code in an infinite loop. The following code is this particular code. Then what we do is after a connection is established, call fork to create a new process. The child process will close sockfd and call do stuff, passing the new socket file descriptor as an argument. When two processes have completed their conversation as indicated by do stuff, they exit. Then the parent process closes new sockfd because all of this code is in an infinite loop. It will return to the accept statement to wait for the new connection. And this is the code snippet that is used. Then there is a zombie problem in it which will be addressed now. When the parent process creates child process for and many simultaneous connections are established, there is always a possibility of a child process creating a zombie process when terminated, and this zombie process will remain as such till that parent process calls wait function. So to identify the zombie process, this particular command is used, which is px then grep z. I would like to speak about the code enhancement that is done on the client side and the server side. Here, for the enhancement, I have implemented a function and a function such that it gives us the prime factors of a given number. So in the client side, we take a number, and then at the server the prime factors of this particular number is calculated and sent back to the client, and at the client side the prime factors are displayed. So let me log into my data lab. Enter. So I have logged in. The same thing here. So I'm gonna SSH into node B. Here I'm gonna SSH into node D. I'm gonna go to this folder Prem. Same thing here. Then ls, then ls. So the required client program is client.cpp. node D, experiment 1, and EE542, and ISI datalab.net, and the port number. So let's say I type 12, and what I get is just the prime factors are 2 and 3. So this is part of my enhanced program, and thank you for watching this video.